Okay, so we're going to talk about the concepts behind solving trigonometric equations for multiple angles or that involve multiple angles. Um, when we have multiple angles, you're changing how fast cosine or sine or any trigonometric function is reaching a particular value. So, for example, let me graph the graph of cosine real quick. So the graph of cosine is going to look something like this. It's going to be symmetric. Okay, so if we were to, so this is cosine of x. Okay, well, if we were to change this to where we had, let's say, the cosine of 2x, what would the cosine of 2x look like? Now that is going to be very different. Um, we'll have the same starting point, but it's basically going to go through its pattern twice as fast. So it's going to reach back up into its maximum here and here. So this will look something more like this. And in reverse, same kind of idea. You're getting twice as much for cosine as you would before. Now, when you draw, let's say we were to look at when this equals a half. So we draw a line when it equals a half. So the intersections here happen a lot more often because you have twice as much going on. But the main thing is that it squeezes. It's not as quite as symmetric as it was. It's still symmetric, excuse me, but it's not quite as simple as how do we figure out where to go with these? How do I figure out what the solutions are? Before, you had this nice gap in between the answers. So these are, answers on the unit circle. And when we look back and say, okay, well, what about our coterminals to these? You know, these are coterminals. These are coterminals. Because they're 2 pi apart from each other. But when we squeeze the circle, or when we smash the graph a little bit, it no longer becomes a distance of pi, right? Or it no longer becomes the same distance. So like these are coterminals in a sense, but they've been squeezed. They're now a pi apart. And there's an easy way to find this, and I'll explain kind of in the next plot. But you see that the answers, there's more answers for cosine of 2x than there are for the cosine of x. So this is the cosine of 2x. And so I'll show you. So let's say we had so the cosine of x equals 1/2. Well, if we look at the unit circle, there are 2 places where this happens. This is going to be pi over 3, and it's also going to happen at 5 pi over 3. Well, each of these, we have to include all of the coterminal angles to that. And so this is a complete solution set. Now, it changes if I do the cosine of 2x equaling 1/2. Well, it starts off exactly the same. You're going to figure out where is the cosine 1/2. Okay, where's the cosine 1/2? But instead of doing the cosine of x, we're doing the cosine of 2x. So we end up with 2x equals these exact same numbers. So again, when we solve for things, we're never interested in what 2 things are. We're interested in what just a single one is. So we have to divide everything by 2, all of these answers by 2. Now that changes the way that this looks quite a bit. The answers are going to look very, very different. So for this one, you get pi over 3 plus 2 pi k, all divided by 2. And, sorry, and this is also going to be 5 pi over 3 plus 2 pi k over 2. When we go back and look for our answers here, we have x equals these two items. Well, we want to simplify this. If you were to add these fractions and divide everything, you could do this pretty simply. You could look and say, okay, well, first part, pi over 3 over 2 is pi over 6. And then we say 2 pi k over 2 is just going to be pi k. then for the bottom part, you're going to end up with 5 pi over 6 plus pi k. So you want to be careful when you do this operation down here, but you can see that the answers are very, very different. Because we have twice as much going on, our coterminals look a little bit different.